Hello viewers, in today's session we are going to discuss another important problem from a domain of functions, and here we have to find out the domain of this function f of x, that is equal to square root of pi by 4 minus tan inverse natural log of x, right? So in order to find out the domain of this function, will make use of this concept, that is the principal value branch of tan inverse theta. It belongs to this interval, that is minus pi by 2 to pi by 2, provided this theta belongs to the set of real numbers. So the range of tan inverse theta, that is tan inverse theta, has values in this open interval, that is minus pi by 2 to pi by 2. So here we have the real number line, and here we have minus pi by 2, and here we have pi by 2, right? So now the first condition to find out the domain of this function is that this term, that is pi by 4 minus tan inverse natural log of x, this term has to be greater than or equal to 0. So the first condition is pi by 4 minus tan inverse natural log of x should be greater than or equal to 0, because this term cannot be a negative term, because inside the square root sign we should have positive numbers, so that we can have the square roots of positive numbers in the set of real numbers. So if this quantity is negative, then we have numbers like square root of some negative number, which does not belongs to the set of real numbers, right? Okay, so now here we have pi by 4 minus tan inverse natural log of x is greater than or equal to 0. So from here we can now write pi by 4 is greater than or equal to tan inverse natural log of x, which can also be written as tan inverse natural log of x is less than or equal to pi by 4. Now see, this number, that is pi by 4, it lies between minus pi by 2 and plus pi by 2. So we have pi by 4 somewhere here. So now let us take this term, that is the natural log of x is equal to theta. So we have tan inverse theta less than or equal to pi by 4, right? So now if we look at this real number line, then here minus pi by 2 is not included, and pi by 2 is also not included, but here we have pi by 4, so this pi by 4 is included. Now this inequality says that tan inverse theta has to be less than or equal to pi by 4, so we must consider this interval, and we cannot take this interval, right? So now we can modify this inequality by writing here tan inverse theta has to be greater than minus pi by 2, because tan inverse theta cannot go beyond minus pi by 2. So here tan inverse theta has to be greater than minus pi by 2, but less than or equal to pi by 4, right? And here we cannot have the equality, because here we have the open interval, right? So now we have minus pi by 2 less than tan inverse theta less than or equal to pi by 4. So now we have to solve this inequality. So now to solve this inequality, let us take the tangent of all these three quantities, that is the tangent function. So we have tan minus pi by 2, and then we have tan of tan inverse theta, and here we have tan pi by 4, and the direction of the inequality remains the same, because the tangent function is an increasing function, right? So here we have minus tan pi by 2, and here we have simply a theta, and tan pi by 4 is 1. So here we have used this result, that is tan minus alpha is equal to minus tan alpha, right? And tan pi by 4, that is tan 45 degrees, is 1. And so now here we have tan pi by 2, and we know that if we have the function say tan x, and when x tends to this angle pi by 2, then tan x tends to infinity. That is tan pi by 2, it tends to infinity. So here we have minus infinity, and here we have theta, and here we have 1. So now let us substitute the value of theta as natural log of x. So we have minus infinity natural log of x, and here we have 1. So now to solve this inequality, let us raise three quantities to the power of e. So we have e raised to minus infinity, and then we have e raised to natural log of x, and here we have e raised to 1, right? So raising these three quantities to the power of e, where e is the exponential number and e is irrational number. So e raised to minus infinity is 0, because we know that if we have the function say e raised to minus x, and when x tends to infinity, then e raised to minus infinity tends to 0, right? So the value of e raised to minus infinity is 0, and e raised to natural log of x is simply x, because this is the well-known result, that is e raised to natural log of x is simply x, and here we have e raised to 1 is e, right? So viewers, the domain of this function is given by x belonging to the interval that is from 0 to e, and here e is included, and remember e is an irrational number, and the approximate value of uh, this number e is 2.718, right? So the domain of this function is given by this interval, which is open from the left and closed from the right, that is from 0 to e. Hello viewers, in today's session we are going to discuss an interesting problem from a domain of functions, and here we have to find out the domain of this function f of x, that is square root of tan inverse 2x minus 1. So here we have to find out all the values, the valid values of x for which this function is defined, right? So here we are again going to use the concept of inverse trigonometric functions, and here we'll see the principal value branch of tan inverse function, right? So from inverse trigonometric functions we know that tan inverse theta, it belongs to the open interval, that is minus pi by 2 to pi by 2, provided this theta it belongs to the set of real numbers, right? So here theta belongs to the set of real numbers, and tan inverse theta has the range, that is the open interval minus pi by 2 to pi by 2. So here we are going to use this concept to find out the domain of this function. So here we have minus pi by 2, and here we have pi by 2, and between minus pi by 2 and pi by 2 we have 0, right? And here these 2 points are not included. So here we have the square root function. So to start with, this function f of x is defined if this quantity which is inside the square root sign, it has to be greater than or equal to 0, right? Because under the square root sign we cannot have a negative number. So this quantity has to be positive or equal to 0, so that the function f of x is defined on the set of real numbers, right? So this is the first condition, right? So here we can take theta is equal to 2x minus 1. So we have here tan inverse theta should be greater than or equal to 0. So now consider this real number line. So here tan inverse theta has the range from minus pi by 2 to pi by 2, and between this interval, that is from minus pi by 2 to 0, we have all the negative numbers, and tan inverse theta cannot be a negative number, because here we have square root of a negative number, which results in a complex number. But here we are dealing with the set of real numbers, right? So here minus pi by 2 to 0, this interval has to be excluded, or we should discard it, because tan inverse theta cannot have values between minus pi by 2 and 0, right? So the acceptable values of tan inverse theta must lie from 0 to pi by 2, because here this interval contains all the positive numbers, right? So we have here a 0, and here we have pi by 2. So here we have closed, and here we have the open end, right? So here tan inverse theta has to be greater than or equal to 0. So if we merge these two aspects here, then tan inverse theta has to be greater than or equal to 0, but it should be less than pi by 2, right? And here we should remember that tan inverse theta here cannot take this value pi by 2, because here it becomes infinite, right? So we have now this inequality, right? So now we have to solve this inequality. So let us take a tan function of these three quantities. So here we have tan 0, and here we have tan of tan inverse theta, and here we have tan pi by 2. So tan 0 is 0, and here we know that from inverse trigonometric functions, tan inverse theta is equal to theta. So here we have theta, and here tan pi by 2. So tan pi by 2 is not defined, that is, it tends to infinity. So here we have infinity, right? So let us now substitute the value of theta as 2x minus 1. So we have 0, here we have 2x minus 1, and here we have infinity, right? So now to solve this inequality for x, let us add 1 throughout this inequality. So here we have 0 plus 1, here we have 2x minus 1 plus 1, and here we have infinity plus 1, right? So here we have 1 simply, and here 1 and minus 1 and 1 get cancelled, and here infinity plus 1 is again infinity, right? So now let us divide throughout by 2. So dividing throughout by 2, here we have half, and here we have simply x. 2 and 2 get cancelled, and here when a large number, that is infinitely large number, is divided by 2, we again get infinity, right? So now here x belongs to this interval, that is half to infinity, because here x is equal to half is included. So the domain of this function is given by this interval, that is half to infinity. So this is how by using the concept of inverse trigonometric functions, we can easily find out the domain of functions of these kinds.